problem from center of gravity, and this is also from your university question paper. And the problem is, find the center of gravity of a semicircular plate, that is the semicircular area, right, of radius A, whose mass per unit area at any point varies as root under a square minus r square, where r be the distance of the point from the center. Here mass per unit area is given, that is rho. Mass per unit area means rho. Rho is proportional to root under a square minus r square. That is, we can take rho, this is equal to k into root under a square minus r square, where k is variation constant. Right. Now we write or we draw here a rough sketch of semicircular area. This is look like this, and this is the total plate. Okay, let it be x-axis, it be y-axis, and this is origin. Clearly, this plate is symmetric about y-axis. So, due to symmetry about y-axis, center of gravity G must be lies on y-axis. Let it be the center of gravity. And this is G, and the coordinate of G is 0, y bar. Right? And y bar is given by integration y dm by integration dm, where dm, this is the elementary mass, okay, at P, at any point P xy. Let the coordinate of any point P, this is xy, on the area, and we know that elementary mass dm, this is rho into dA, this is elementary area, and we consider here an elementary area, this is dA. Now in the formula y dm, we can write this is integration y rho dA by integration rho dA. Okay. Now we consider here in polar coordinate. So in polar coordinate, elementary area, this is dA, this is r dr d theta. Sorry, r dr d theta. Okay. And y, this is equal to r sin theta. So we get in the numerator, let it be n and it be d, numerator and denominator. We find numerator and denominator separately, then we put the value of n and d and getting the value of y bar. Now n, this is given by double integration, the range of r and theta 0 to a, because the radius of the semicircle is a, and this is the range of r, and the range of theta, this is 0 to pi, because here theta equal to 0 and here theta equal to pi. Okay. So r equal to 0 to a and theta equal to 0 to pi. The value of y we put here, this is r sin theta, and the value of rho means k into root under square minus r square. And now put the value of dA, this is given by r dr d theta, r dr d theta, and get the value as k into double integration 0 to a and 0 to pi. This is sin theta, and this is r square into root over a square minus r square dr d theta. And we can integrate this term separately because theta and r are both independent. So this is 0 to pi sin theta d theta, and integration 0 to a r square into root over a square minus r square dr. For the second integration, we put here r, this is equal to a sin phi. Then the range from r to phi is given by 0a, and this is 0 to pi by 2. And dr, this is equal to a cos phi d phi, and we put the value of r and dr here, and integrating sin theta, this is minus cos theta, and the ranges are 0 to pi. And from here, this is 0 to pi by 2, this is r square. R square means a square sin square phi, and a square minus r square, this is a cos phi, and dr, this is also a cos phi, so a square cos square phi d phi. From here, k into, this is minus of minus 2, because cos phi equal to minus 1, cos 0 equal to also 1. And from here we get a to the power 4 into integration 0 to pi by 2 sin square phi into 1 minus sin square phi d phi. So this is 2k into a to the power 4 into, this integration is sin square phi, the integration of sin square phi is half into pi by 2 minus sin to the power 4 pi, this is 0 to pi by 2 also, and so this is 3 by 4 into half into pi by 2. Right? We use the formula of gamma function, and this gives 2k a to the power 4, take common pi by 4, this is 1 minus 3 by 4, so we get 2k a to the power 4 pi by 4 into 4, this is 4, 1 by 4, so we get k a to the power 4 pi by 8. This is the value of n. Okay. Now we find the value of d. What is d? D is given by, this is also theta equal to 0 to pi and r equal to 0 to a. There is no y, so no r sin theta, only rho and only r dr d theta, because rho into d. So we get k into root under a square minus r square into r dr d theta. Integrating with respect to theta, we get here k into theta, this is 0 to pi, and for this integration we get, or we put a square minus r square, this is equal to z square. So this is minus 2r dr, this is equal to 2z dz, and 2 to cancel out, so r dr, this is equal to minus z dz. And changing the limit from r to z, r equal to 0 to a, and this is a to 0. Okay, so the second integration is z equal to a to 0, we get r dr, this is minus z dz, and from here we get another z, so this is z square dz. And integrating we get k into pi, this is z2 by 3 and the ranges are 0 to a. So clearly this is aq by 3. So we get the value of d. The value of d is k pi aq by 3. Okay. We get the value of n here. We get the value of d here. So y bar is equal to d by n, and this is k a to the power 4 pi by 8 by a pi aq by 3. So k cancel out, pi cancel out, aq a to the power 4 cancel out, here a remains, and this is a by 8 into 3 by 1. So 3a by 8. And the coordinate of CG is g given by 0 comma y bar. So this is g 0 comma, this is 3a by 8. Okay. So we get the coordinate of semicircular area whose density is not fixed, whose density is varies with root under a square minus r square, and where r is the distance from the center of the circle. Okay, and this is our solution of the problem. Thank you for watching.